And these are generally calculator questions unless the numbers are really, really, really simple. But generally, these are calculator type questions. Have you done physics and science yet?
Yes.
No.
Does the number 9.8 mean anything?
No.
Yeah, it's the force of gravity. So if you haven't done physics yet, you'll come over to that over and over and over. It's always 9.8. So a lot of these will have variations of 9.8. This one has 4.9, and then the exponent of 2. If you multiply them, you get 9.8. It's really, really common in these kinds of questions. Because when a ball goes up and it hits at maximum, what happens after that? Gravity brings it back down. So those numbers are really, really common. So what do we really need to know here? Well, I don't really care what kind of ball it is. I care that I'm dealing with the height of an object, and I care about the units in meters. I care about the equation. What is t? Because we're used to seeing x and y, but this has h and t. H is height. What do you think t represents? It's going to be time. A couple things we want to find. Maximum height. At what time does it reach its maximum height? At what time does it hit the ground? And what's the height 1 second after it was hit? So again, in terms of the math, I don't care if it's a soccer ball, a baseball, whatever. That's what physics people care about. We just care about the pure math. You'll recognize these problems because they typically have to do with the height of an object, and the formula is always given to you in the equation. So what we're going to do is start by graphing it. So let's see how much you remember from last semester. I'm assuming you graphed lines last semester? A little bit. Have you seen the graphing function before?
Yeah.
Okay, so you've been into y equals. So I always start with saying clear out the crap. So if you've got crap in there, get rid of it. Did you talk about last... Did you talk about last semester about finding intercepts or finding anything on a graph using your calc?
Yeah.
You did, okay. So first thing I'm going to do is just graph the equation, so negative 4.9. I don't have a t button, we just use the general variable button, so it's going to show up as x plus 22.8x. We're going to start with Zoom Standard and see what kind of picture that gives us. What do we press when we go into Zoom? Number 6. And what Zoom Standard does is sets the axes negative 10 to 10. Does that give us a really good picture of our parabola? No, we're missing the top half of it. So generally you start with Zoom Standard. It's typically not going to work. Then we're going to go into Windows and use a little bit of logic to set the values ourselves. We put Zoom Standard. Now, you need to use a little bit of logic here because we're dealing with context of height and time. Can we have negative values with a height? Well, only if we're somehow digging underground and then hitting our golf ball, which doesn't make sense. Could we have negative time? Not in this universe. So I'm going to set the y min as 0 because time can't be negative. Natasha?
For the whole, I remember you taught us how to change the actual Cartesian plane itself if the parabola didn't fit in it. 0 is Zoom fit. We do.
Yeah, we're going to do it by hand for these ones, though.
Oh, okay.
You still with me?
Yeah.
I'm going to keep it as 10 because we could see the other half of our parabola. We could see both left and right, so that's okay. I'm going to come now to y, which was height. I'm going to set 0 for height, obviously. Now, we couldn't see the top section, so we obviously need to go higher than 10. So give me a number that's higher than 10.
50.
50. First one I heard. Do we have to choose 50? No, we're just trying to get a picture of what this parabola looks like. Can we see the whole thing? Can we see the max min? Can we see where it crosses? Okay, so this is a pretty good picture. So first thing I'm going to do is just do a little sketch of what I put on my screen. And I'm just going to add the values of what my screen was. Ooh, 50. Just so later we know roughly what these values we're talking about. I'm going to label the axes. The bottom is time. And we're assuming it's in seconds if the question doesn't say. Y is the height, and it's in meters.
My parabola came out different. Why you see a line?
Did you put the squared in the equation? window.
Yeah, I'm positive I have it right. Yeah, negative 4.9x squared plus 22.8.
And because you're using your phone, I have no idea because they all work differently.
Can I see how you drew yours? Like, on your, the physical paper.
Mine's a TI-84.
Does it start at 0?
It should, yeah, because 0 is going to be time and the height's going to be on the ground. So it makes sense.
I know it's on my phone, but that should not have.
Because on mine it doesn't really look like it starts at 0.
It's approximate. It's just because we've gone up to 50, so it's really kind of squishing it around the 0. It should start at 0.
Oh, okay. How did we know the time? Did we just like use our common sense?
Yes, because when we originally used Zoom Standard, we could see the left and right of the parabola, so we knew we were okay till 10.
No, I meant like for time and height. We just like.
Oh, because they're defined by the equation. So x is the same as time, which is the bottom of the graph, and height is the same as y, which is the side.
X and Y mins are 0 and X and Y maxes are 50, right?
No, we did x max to 10.
Oh, damn it.
We got this sorted. Everyone's got the same picture. We're doing okay. We know how we got there. What the first question for is asking for the maximum height, and that's just saying what is the maximum height of this parabola. So what's the max is what we want to find. You should have looked at this last semester. If you didn't, I'll review it. Anytime you want to calculate anything on the graph, you're going to go into the calc menu, which is second function trace. And you probably only used 1 and 2 last semester. Now we're going to look at 3 and 4, because obviously minimum and maximum. If we look at this graph, do we have a max or do we have a min? So I'm going to pick number 4, max. And right now it's telling you where the cursor is. My cursor's at 5, negative 8.5, so I need to bring it back to the top of the graph. So I'm just hitting the left-hand arrow, and I call it the spider. It's the little cursor. Do you see the spider that kind of like... Mine was on the very right of the graph. It depends where yours is, so they'll give you the coordinates on the bottom. We're going to the left-hand side of the Maxmin. Yeah, so right now I'm on the very top, and I'm not doing anything else. So sometimes you have to hit the arrow a lot to get it to come up. It just matters where your calculator put it. But you should see it kind of flashing on there. And it doesn't matter so much for parabolas, but next year when you get into different graphs, we're going to look at graphs that have multi-max and min. So they might have 3 maxes and 5 mins, or 2 maxes and 1 min. And so you have to tell the calculator which max or min you want it to find. And you do that by going to the left of the max you want to find, hitting enter, then moving to the right of the max you want to find, hit enter, then hit enter a 3rd time. So I'm going to go somewhere on the left. It doesn't matter how close I am. I just need to be physically on the left-hand side. And I'm going to hit enter, and what it should have done was put an arrow at the top. And at the same time, it has now flipped and asked for the right bound value. So I'm using my arrow and going somewhere on the right-hand side. Again, doesn't matter if you're close to it, if you're further down, as long as you're somewhere on the right.
Why do you go on the left if you're trying to find the max?
Because that's what the calculator asked for.
Okay.
Then I'm going to hit enter. And so what it's done is it's put 2 arrows at the top, and it's asking, is the max between these arrows? It's like pointing, is this the max you want to find? Again, not a big deal when you only have 1, but when you've got multi-ones, you have to tell the calculator. If the arrows are good to go, you hit enter the 3rd time. And what it's actually done is not only given you the max, it's given you the entire vertex at the same point.
What did we have the Y min at again?
The y min was at 0.
Okay.
Questions on how to find the vertex? Did you all find the same value?
No. So we're figuring out how to double my parabola is so high, so tall.
You move to the right, left bound, you're on the left.
That just means you didn't go very far. You moved very far to the right. So like if it doesn't matter like the exact amount of like the one on the right and the one.
As long as you're physically on the left and physically on the right. Just pausing, making sure everyone's okay. So in terms of our ball, what they have told us is that the maximum height is 26.5, and the x-coordinate at that point is 2.3. That's what it's given us, is both the x and the y. So part A, picking it right off the vertex, what's the maximum height this ball reaches? 26.5, give me some units. Meters. That's really high for a ball. That's really high. B, what time did it take to reach that maximum height? Well, that's just the x value of the vertex. So how long did it take to get there? 2.3 seconds. What's the time it takes the ball to hit the ground? So we want to know all the way to the other side of this parabola, what was the time? Well, what do you know about the symmetricness? I don't think that's a word.
Is that just one of the
I think I might have made that up. Symmetricness, symmetry, the symmetry of the parabola? Well, if the halfway is 2.3, how long did it take to go the full way? 4.6. The last question wants to know just 1 meter, so approximately here. What is the height at 1 meter? So not quite halfway here, but somewhere in there, approximately 1.
1 meter,
1 second, sorry, 1 second. Anytime it asks you anything different than the vertex or the x-intercepts, it's going to be direct substitution. So we're going to go back to the formula, and we're going to put 1 in for time. And so my other side's going to be negative 4.9, 1 squared, plus 22.8 times 1. Bless you. And then that's just a straight up calculator question, so I'm going to quit out of the graph and just go back to the home screen. And I'm going to type in exactly what I see. So negative 4.9, open bracket 1, close bracket, squared, plus 22.8, open bracket 1, open bracket, close bracket. I don't want to hit enter because I don't want to spoil the fun. 17.9? Okay, so if we want to calculate the height at any particular time, it's just going to be direct substitution. Those are height problems. That's the way they're always going to work. Read to read number 2. Natasha, you need to leave until you can calm down, please. Go for a walk.
I'm sorry.
Just go for a walk. Come back when you're calm. What's number 2 about? You're on the number 2 below. We're still up here on number 2. They're all like, soccer, you're like chickens. We're like, what? So height, fact is a soccer ball. Really, I don't care. The other is horizontal distance. And we have this lovely equation. So this one has not given us height and time. They have not mentioned time at all. It's irrelevant to this particular question. What have they given us? Vertical distance and horizontal distance. So how far has it gone up? How far has it gone over? So nothing to do with time for this particular question. Part A wants max height. B wants the horizontal distance where it reaches its max height. C wants the horizontal distance till it hits the ground. D wants the height when it's 10 meters horizontally. C wants the horizontal distance when it hits the ground, so how far does it travel? And E wants to know something about an opposing player, something, something, head the ball. Well, for non-soccer players, what does it mean to head the ball? Hit it with your head. So something about this 34 meters, something about heading the ball. Same thing, let's start with the picture and see what we're dealing with here. Clear out what you have in your y equals, put into the new equation. Note that it's negative 0.025, not just 0.25. Now again, if we go to zoom 10, which is our normal one, we're not going to see much of the parabola at all. We need to go way more to the right. So let's go into window. Can we have 0 horizontal distance? Okay, so I'm going to start with 0. 10 wasn't enough. I needed way more than 10 because I couldn't even see half the parabola. Thoughts? Going down to the height, I can put 0 for the height. 10 didn't look like I could see very much. Let's do 30. Remember, you're not locked in. If those are not good numbers, you can just come back to window and change them. So if we go graph, do we have a pretty good picture of this parabola? It's a little bit small, but that's not the end of the world. So it means we just were a little bit over with the two x values, or two max values. But it doesn't matter, as long as I have a little picture. And that's why it's important we put the little values, otherwise all the graphs look the same. However, this is a real difference between a graph of 10 and a graph to 100. Not height this time. What's the bottom going to be? Horizontal distance, which was in meters. Y is still the height, still in meters. We're going to have to find the vertex just like the last one because that will give us the maximum height. You walk me through. How do we find it from a graph? I call it second calc because I like to mention what the actual menu is, but whatever you want. Number 3 or number 4? Which, if you look at the equation, we could have got that right from the equation. I just want you to practice doing it on your calc. So that tells us the max height is 10. How much did it travel horizontally when it hit that height? 20. I haven't started. I'm just labeling the graph right now. Okay, A, max height. 10 what now? Horizontal distance when it reaches the max height. Horizontally until it hits the ground, so all the way back to the other x-intercept. Has to be 40. Why? 20 times 2. What's the height of the ball when it's 10 horizontally from the kicker?
Wait, I have a question.
Mm-hmm.
If C was asking how far did the ball travel horizontally,
Mm-hmm.
wouldn't we multiply 10 by 2?
Except that's the vertical height is the 10. We want the horizontal distance.
Oh, I labeled mine backwards. Okay. Do we always multiply by 2?
If we're going the whole distance, yep. How are we going to find the height when it was at 10?
Just substitute it into the original equation.
Exactly what we did in the last question, so go back to your home screen. Negative 0.025, open bracket, D's going to come out. We're going to sub in 10. I don't want to ruin the fun. $7.5.
Yes.
Okay, wait. Does that make sense, though? If it was 20 horizontally and 10 vertically, why isn't 10 giving me 5 vertically?
Because exponential numbers.
Not quite. So if 20 was 10, why isn't 10 5? Because it's curved. That would be a linear function, right? So that was great last year when you were doing lines, or last semester. You can't assume with the parabola that it's going to be half. E. What are we trying to figure out in E? Not fence and chickens. We'll get to them on Monday. Where is this dude? 34 of the way in, so maybe here-ish. How do we know if he's going to be able to head it? Well, we're assuming he's probably normal height for a typical male. More importantly, we need to know is where's the ball, and that we can calculate. Where is the ball at that point?
Sub in there.
Now recall, don't type it all in again. I've taught you second function entry before. So now just go back to the 10, take the 10 out and put in 34. .1 meters. Well, I'm about 1.5 meters. Don't mock me, it's genetics, it's not my fault I'm short. But I'm about 1.5 meters. Could I jump up in theory and hit a ball at 8 or at 5.1 meters?
No.
Probably not so much. Could an average male jump up? Probably 5 meters. Probably not. So no, the ball is too high.
No, he couldn't.
How tall are you in like foot?
5'3" and a quarter. And when you are under 5'4", that quarter is very important.
Oh, I know I'm 5'2".
Yes, it's very important. They wouldn't put it on my license. I got upset. Questions? Pause, which means no homework for the weekend, which is kind of nice.